Good morning students, I am Vikas Kumar Pandey, PGT Chemistry. I welcome you all in Chemistry Practical class. In the previous video I discussed about how to prepare a standard solution, and in this video I am going to discuss about how to prepare a standard solution along with the titration, in which we find the strength and molarity of an unknown solution with the help of the known solution. See, what is the aim? Determine the strength of the given sodium hydroxide solution with the help of M/20 oxalic acid solution. With the help of M/20 oxalic acid solution, whose concentration is known, we have to find the molarity and strength of this given sodium hydroxide solution. See, first, what are the apparatus required? The first is burette. This burette is used for the titration. Second is pipette. This pipette is used to measure the exact volume. This is conical funnel. This is measuring flask in which standard solution is prepared. This is titration flask. This is watch glass. And now the chemicals required for this practical. This is phenolphthalein. We use phenolphthalein here as indicator. And this is the oxalic acid. And this is the given solution of sodium hydroxide whose concentration is unknown. We have to find the molarity and strength of this given NaOH solution. See, what is the theory? In this experiment, NaOH solution is taken in the burette. We take NaOH solution in this apparatus. This is burette. And the known solution, the known concentration solution of oxalic acid is taken in this titration flask. See, what is the chemical reaction? The chemical equation for this reaction is, this is oxalic acid, this is sodium hydroxide, and the product is sodium oxalate plus 2 molecules of water. See, this is a balanced chemical equation. COOH2 means oxalic acid is 1 mole, NaOH is 2 mole, and sodium oxalate produces is 1 mole, and the water produces is 2 mole. See, what is the indicator here? The indicator is phenolphthalein, because the alkali which we have taken is NaOH, which is a strong alkali. When we take strong alkali, we take phenolphthalein as an indicator. Next, see, what is end point? What is end point? In this titration, the end point is colorless to pink. The first initial color is colorless, and then it turns to a permanent light pink color. As phenolphthalein, the color of phenolphthalein in acidic solution is colorless, and in basic solution it is pink. Next, see, this is the observation table. And these are the serial numbers. We take 3 readings, minimum 3 readings. This is the initial reading. This is the blank for the initial reading. This is the blank for the final reading, and this is blank for the difference. Means how much NaOH is used in the titration. And when 2 or more readings remain same, we call it concordant reading. This is the blank space for the concordant volume. See, what are the calculations? As we know from the molarity equation, V, or volume of oxalic acid, into molarity of oxalic acid divided by molarity of sodium hydroxide multiplied by volume of sodium hydroxide. And these are equal to the number of moles of oxalic acid divided by the number of moles of sodium hydroxide which is present in this balanced chemical equation, which is 1 for oxalic acid and 2 for sodium hydroxide. See, when we put the value, this 20 is the volume of oxalic acid which we pipette out. 1/20 is the molarity of oxalic acid which is given in the question. Molarity of NaOH we have to find, and volume of NaOH is the concordant volume, which is equal to 1/2. From there we calculate the molarity of sodium hydroxide, which is equal to 2 upon x. When we solve this, 20 and 20 cancels, which is equal to 2 upon x. What is x here? X is concordant volume. And after finding the molarity, we have to find the strength of given sodium hydroxide solution. And what is the strength? It is the molarity into molar mass. Molarity into molar mass. And when we solve this, we get 80 divided by x. What is x here? It is the component volume. When we put these values, we get the strength of oxalic acid in gram per liter. Okay, now I am going to discuss about the procedures related to the experiment. First, we have to prepare the standard m/20 solution of oxalic acid. And for this preparation, we need 1.57 gram of oxalic acid crystals. The process remains the same. The process remains the same as in the previous video I discussed about the how to form the standard solution of oxalic acid. This is the standard solution of oxalic acid, m/20 oxalic acid, in which I dissolve 1.57 gram of oxalic acid in 250 ml of water. This burette is first washed with distilled water and then with the NaOH solution which we have to keep in this, so that the no alteration of volume needed. Now we have to put this funnel on this burette and fill this with the sodium hydroxide solution. As the water level, as the NaOH level is above the mark, so we need to make it as the lower meniscus just touches the glass mark. So I am removing some amount of NaOH so that the glass mark, the lower meniscus just touches the glass mark. See, the just touches the glass mark. This gives us the exact reading, and this shows that this is the 50 ml of NaOH solution. Now we have to pipette out exact 20 ml with the help of this pipette and transfer this into the titration flask. See, this is the exact 20 ml volume of oxalic acid which you have to transfer in this titration flask. This is the 20 ml of standard oxalic acid solution. Now I am putting 1 or 2 drops of this phenolphthalein indicator. See, as the color is colorless because phenolphthalein in acidic medium, the color of phenolphthalein in acidic medium is colorless. Then we have to titrate it against this sodium hydroxide solution. Add this dropwise and shake the flask continuously. And the end point is the color changes from colorless to permanent light pink color. As the color of phenolphthalein is basic medium is pink color. See, as the drop reaches the oxalic acid solution, it changes to pink, but as I shake this pink color disappears, which means no end point is reached. End point is not reached. The whole solution is not neutralized. And we place a white paper in this or a white glaze tile so that the little color change in color will be observed. See, this is the permanent light pink color. This is the permanent light pink color. And see, what is the reading? The reading is 22.6. The volume which is used here is 22.6. And throw this in this basin and repeat this experiment with the same volume of oxalic acid. This contains the same volume, that is 20 ml of standard oxalic acid solution and 2 drops of phenolphthalein indicator. Then add this NaOH dropwise and shake the titration flask. The color is just light pink. The color is just light pink. See the reading. The reading is 45.1. The reading is 45.1. And the repeat volume. As the volume remaining of NaOH is very less, so I am taking from the initial, that is 0. This contains 20 ml of oxalic acid solution with 2 drops of phenolphthalein indicator. See, the color is lightest permanent pink. See the reading as 4.9 ml of the previously filled purity is left, and the next reading is 17.6, which means the final reading is 17.6 plus 4.9, which is 22.5, which is 22.5. See, the initial is 45.1. The initial is 45.1, but we add the more volume by filling the burette completely, so the difference is, so after adding these two we get the final volume, which is 67.6. See, this is the sum of 4.9 from the previously filled burette and 17.6 from the newly filled. When we subtract this, we get 22.5. See, as these two are the same reading, we call this same reading as concordant volume. See, the concordant volume is 22.5. The concordant volume is 22.5. Now move to the calculation part. As the concordant volume is 22.5 ml, so we have to calculate the molarity of NaOH. The formula is V oxalic acid multiplied by M oxalic acid divided by M NaOH. This M is molarity and this V is volume into V NaOH. When we put the values 20 into 1 by 20 x into M NaOH, we get molarity of NaOH is equal to 2 upon x. And what is x here? X is concordant volume. And as we know, the concordant volume value is 22.5. So the molarity of NaOH is 0.088 capital M, means mole per liter. Then we have to find the strength of NaOH solution. The strength of given NaOH solution. The formula for strength is molarity of NaOH multiplied by molar mass of NaOH. The molarity of NaOH just we find is 0.088 multiplied by the molar mass of NaOH is 40, which is equal to 3.55 gram per liter. This is 3.55 gram per liter. This is the strength of given NaOH solution. So by this we calculated the molarity of NaOH and the strength of NaOH by using the standard solution of oxalic acid. Okay, thank you.